Hello, I'm Dr. Julie Brown. I practice pediatric emergency medicine and I have a special interest in anaphylaxis and epinephrine auto-injectors. It's winter and lots of people have been asking about how to keep their auto-injector safe in the snow and when they're skiing and when they're out having fun enjoying the winter weather. So I thought it was a good time to talk about epinephrine auto-injectors and temperatures. To begin, let's start with how these auto-injectors are supposed to be stored. The manufacturer instructions tell you to store them between 68 and 77 degrees Fahrenheit, which is 20 to 25 degrees Celsius, and excursions are allowed between 59 and 86 degrees Fahrenheit, or 15 to 30 degrees Celsius. It's worth noting that these temperatures reflect standard room temperatures, as in the drug was approved for use at standard room temperatures. It wasn't that this has to do specifically with the temperature within which epinephrine is known to be stable. It's that they tested and showed that epinephrine is stable within this established standard room temperature range. So there's a difference there, because what it means is it's not been tested and shown to be stable at temperatures outside of that range, and it maybe could also be stable at other temperatures, but it wasn't FDA approved that way. So there are two questions we need to answer if we want to know if the device will also be stable outside of these recommended standard room temperatures. The first is, does the temperature degrade the epinephrine, whether it's stored inside a syringe or an ampule or however it's stored? So here I've shown you how epinephrine is stored in an EpiPen in the top image and an Auvi-Q in the bottom image. So would that epinephrine be stable if it were hotter than those temperatures or colder than those temperatures? The second question is, does the temperature damage the auto-injector device? And that's a very separate question, as illustrated by this image. I took this picture after putting these devices in my oven at 225 degrees. And you can see that the oven has melted the cases of the device, and you can see the needles poking out there. So the auto-injectors have all fired as a result of heating and probably melting the components that kept the devices from firing. So it's completely irrelevant whether or not the epinephrine has degraded, because those devices are clearly destroyed. So those are two separate questions, both important. So we're going to tackle each of these two questions separately and look at the evidence both for heat and for cold exposure and how that has been studied in terms of each of those two questions. So in terms of epinephrine and exposure to heat, first of all, it's helpful to know how hot a device can get, and there are some studies that can help us there. In this study by Rutland, he took a black medical bag and put it in different places in a car and looked at temperatures both inside and outside of the bag in different locations. And the hottest place was inside the bag on the back shelf of the car, location B in that diagram. And in that location, on a sunny parking lot with moderate temperatures, it was 24 degrees Celsius or 75 degrees Fahrenheit outside. The temperatures inside the black bag rose to 80 degrees Celsius or 170 degrees Fahrenheit in that study. In a similar study there by Vanos, they monitored temperatures in a number of different cars, both in the sun and in the shade, and I'm just showing you here the results of these cars placed in the sun. And there was much more data than what I'm showing you here, but I'm showing you the part that included the highest temperatures recorded, and temperatures went as high as 85 degrees Celsius or 185 degrees Fahrenheit on these peak days. And the highest temperature I've actually seen recorded was actually done by an allergy mom and home scientist, Eileen Rodarmer, who did this in her own car in Colorado. It was outside, it was in the mid-90s. She has a dark blue compact car that she put facing south in the full sun. She was using a dew point Bluetooth sensor beacon, and she had many days of testing, and the highest temperature that she ever reached with this beacon on her dash was 90.8 degrees Celsius or 195.4 degrees Fahrenheit. Fairly impressive temperature there. So you really can reach fairly high temperatures in the sun, particularly if you're on the dash or somewhere directly exposed to the sun in a car. The next thing we need to think about is that epinephrine comes in many forms. First of all, there are two common concentrations. There's 1 milligram per milliliter. That's what's commonly used intramuscularly in anaphylaxis. And then there's a much more dilute concentration, 0.1 milligram per milliliter, which is what is commonly used intravenously for cardiac arrest and other resuscitation. The 0.3 milligram or adult epinephrine auto-injectors are all 1 milligram per ml. The lower dose auto-injectors are often diluted so that the amount injected can be the same. So, for example, the 0.15 milligram EpiPens, the junior EpiPens, are 0.5 milligrams per milliliter. It's also worth noting that different devices and different storage options for epinephrine, such as ampules and vials versus auto-injectors, all have slight differences in the preservatives used, and the preservatives have changed somewhat over the years. Now, the amount of preservatives in these devices are very small, but this still may have some impact on how epinephrine degrades over time, because they are put in with the epinephrine to help prevent degradation of epinephrine. So now we're going to look at specific studies that have assessed the effect of high heat on epinephrine stability and degradation. And I'm not going to present every study that's been done. What I'm going to do is present the studies that looked at concentrations that are relevant to epinephrine auto-injectors and a few studies that are very sort of clinically relevant as well. So here's the first study. This study by Grant. He took 10 epinephrine samples. 5 were 1 milligram per milliliter and 5 were 0.1 milligram per milliliter. And he heated them up to 158 degrees Fahrenheit or 70 degrees Celsius for 4 hours a day for 12 weeks. And then he looked at the results for each of those two concentrations. And for the 1 milligram per ml samples, which is the concentration that is comparable to EpiPens and other epinephrine auto-injectors, there was no significant degradation by assay for that whole duration of study, up to 12 weeks. And that was equivalent to 672 hours of heat exposure. However, in the 0.1 milligram per milliliter epinephrine group, there was no significant degradation for the first 4 weeks, which was 224 hours of heat exposure, but there was degradation from 8 weeks onwards, and that is starting at 448 hours of heat exposure, with only 36% of the epinephrine left at 12 weeks. And you can see that in the graph there. So a notable difference in outcomes for the less concentrated 0.1 milligram per milliliter epinephrine compared with the more concentrated 1 milligram per milliliter epinephrine. Rashid has done a study looking at EpiPens, and he exposed them differently to 158 degrees Fahrenheit. He either did that cyclically 20 hours a day for 5 days and then tested them while hot, or cyclically 20 hours a day for 5 days and tested them while cool, constantly for 5 days and tested them while hot, or constantly for 10 days and tested them while hot. The best outcomes were the 5 days of cyclic exposure where they were tested when they were back at room temperature, and in that group there was still 82% of the labeled dose. An industry standard is to have 90% or higher of labeled dose, so he definitely saw some degradation of epinephrine in this study. The worst was the 10 days of constant exposure that was tested hot, and there was only 60% of the labeled dose in those samples. And he did fire all of those devices and noted that all 20 of those heated devices fired correctly. So here's a little summary of those studies. This is adapted from Parrish et al., and you can see the reference there, and you could also go to that systematic review and see other studies that have looked at heat as well. But you can see that for the epinephrine, that is the one that the concentration that you're going to find in EpiPens, the results were variable there in terms of seeing significant degradation of epinephrine. There is also a study that looked at the more sort of clinically relevant scenario of epinephrine that is stored in emergency vehicles that are used in very hot places. And this is resuscitation epinephrine, so it's the 0.1 milligram per ml. And they looked at vehicles in 7 sites, and they were exposed to, in some cases, very high temperatures, and you can see the mean temperatures there, and they found no degradation by assay in any of their sites. So that brings us to conclusions for heat, because there are no other studies that have looked in depth at device integrity. We're hoping to do some of those in the future, but currently that one small study by Rashid is really the only study that has assessed device integrity in a very limited way. So in conclusion, high temperatures produced variable results in terms of epinephrine degradation. The degradation occurred in some studies of 1 milligram per ml and in some of 0.1 milligram per ml. Continuous heat exposure is worse than intermittent heat exposure, and longer cycles of high heat cause more degradation than shorter cycles of heat for the same total heat exposure. And it's worth noting that in these studies, the cycles of heat were quite long, often 20 hours and multiple cycles that were studied. So moving on to epinephrine and exposure to cold. First of all, there is an interesting study that came out of Europe where epinephrine is routinely stored in the refrigerator, and but sometimes on hospital wards it's stored in room temperature dispensing machines. And so they looked at whether there was degradation of their samples that weren't being stored in the refrigerator versus those that were. And they assessed the degradation that was happening over 12 months. And they found significantly less degradation by assay in the samples that were stored in the refrigerator versus the samples that were being stored at room temperature. Next, Grant, who had done those studies of heat, also did some studies of cold, and again he studied both 1 milligram per ml and 0.1 milligram per ml samples, and he studied them at just above freezing, so 36.5 degrees Fahrenheit or 2.5 degrees Celsius, and he maintained them at that temperature for 12 weeks and then tested them, and he noted no significant degradation of those samples by assay. Beasley took 6.3 milligram EpiPens, and he extracted the epinephrine from them, and then he froze those samples at minus 13.7 degrees Fahrenheit, which is minus 25.4 degrees Celsius, for a week in cycles. So he would freeze it for 12 hours, thaw it for 12 hours, freeze it for 12 hours, thaw it for 12 hours for a week. So that came out to 84 total hours of freezing exposure. And then after a final thawing, he compared the amount of epinephrine in the samples with controls that had been kept at 23.1 degrees Celsius. And the mean concentration of epinephrine in the freeze-thaw samples were statistically significantly higher than the controls, 1.07 milligrams per milliliter versus 0.96 milligrams per milliliter. But while that's statistically significantly different, you can imagine that that maybe doesn't have any important clinical significance. Those numbers are so close together and so close to 1, which is the expected value. So clinically, the importance of this study is really that there is no significant degradation of epinephrine seen by assay as a result of that freezing. And Rashid, again, did a study of freezing. He took EpiPens and he froze them and he tested the epinephrine on thawing. And he once again did different patterns of freezing. He did 5 cyclically for 20 hours a day for 5 days, 5 constantly for 5 days, and 5 constantly for 10 days. There was then one group that was tested cold but not frozen, and that was kept cold constantly for 10 days and tested immediately. And in all of those groups, he found no significant degradation by assay. And all 15 of the devices that he tested fired correctly. So putting all of those results together, as again was done by Parrish et al. In this systematic review, you can see that it doesn't matter how it was studied, whether they cooled it or froze it, and whether they tested it cold or after being rewarmed. None of these studies found any degradation of epinephrine. Now, of course, none of them actually fired EpiPens frozen, and I wouldn't expect that to work. But as long as you didn't do that, all of these studies had very similar conclusions that epinephrine does not degrade with cold or with freezing. So when it comes to cold exposure, we've had a more encouraging answer to our first question: does the temperature degrade the epinephrine inside our syringe or vial? So what about our second question: does the temperature damage the auto-injector device? I had the pleasure of working this summer with undergraduate investigator Alex Cooper, who set out to answer that question. And his aim was to determine whether 24 hours of freezing followed by thawing changes the volume of epinephrine solution fired from an EpiPen device. The methods of the study were as follows. He studied 104 pairs of expired post-consumer devices, 52 pairs of EpiPens, and 52 pairs of EpiPen Juniors. Each pair had the same lot number, expiration date, and consumer. And by doing it that way, we hoped that the pairs had been exposed to similar circumstances throughout their time in use. One device in each pair was frozen at minus 25 degrees Celsius for 24 hours and then thawed, and the other was stored within the recommended temperature range. And then what Alex did was he fired off both the frozen thawed device and its pair into meat. And you can't really see that there's meat here because it's covered by a rubber glove, which aimed to just make sure none of the epinephrine splashed and wasn't counted. But what he's doing is firing it off into a little chunk of meat that's underneath there. And then he's measuring both the increase in weight of the meat on a very sensitive scale, and he's measuring the decrease in weight of the EpiPen. So you can see those two scales measuring those two things. And here is the very scientific-y conclusion to that, and I'll read that for those scientists in the audience who want it presented that way. In unadjusted comparisons, there was equivalence, because we actually tested for equivalence rather than a difference because we didn't expect to find a difference for both outcomes, the increase in meat mass and the decrease in device mass, with a very significant p-value, indicating that frozen thawed devices fired a similar mass of epinephrine solution compared with paired control devices. Testing continued to show equivalence for both frozen thawed devices and control devices after controlling for device epinephrine dose, 0.3 and versus 0.15 milligrams, and expiration date. And here is that same result presented graphically for those of you who like your information presented that way. But the bottom line is that freezing did not impact the amount of drug that ejected from the EpiPens. In this study, we also froze and thawed another 104 EpiPens, 52 of each, and we opened these untriggered so that we could inspect them for any damage or issues that might result from freezing. And we found no cracked vials or other damage detected. The rubber needle cover was still nicely in place. The liquid contents could not be expressed with pressure, indicating that the seal remained intact. And freezing did not appear to have damaged the device in any way. So, in conclusion, when it comes to cold, refrigerating or freezing did not result in significant degradation of epinephrine. Refrigeration resulted in less degradation than room temperature in one study. 24 hours of freezing did not appear to damage EpiPen devices after they have thawed. It's important to note that devices will not work while still frozen. The needle will just come out through the frozen medication. Repeated cycles of freezing have not been tested in terms of device integrity. And other epinephrine auto-injector devices with different designs have not been tested, and these would need to be tested separately as they might behave differently. So how should this change your behavior? Well, I would say that you should perhaps worry less about the uncertainty around possible brief and limited temperature excursions, especially those excursions involving cold. And I would say you should consider refrigeration when overheating is a risk. For example, if you know you're going to spend a day at the hot beach and you have no way to keep your auto-injector cool, you might do better off placing it in an insulated case in a cooler rather than keeping it exposed to heat on a sunny day. Finally, before we finish, I want to just address one more thing because this comes up often. You cannot use a clear appearance in the device window as evidence that the device didn't get too hot or too cold. You can have a nice, clear-looking window and still have degradation. So first of all, I show you here on the left what degradation can look like. If you expose epinephrine to light, you definitely get color change as shown here. And if you ever see this kind of color change, that is clearly bad. You are clearly seeing evidence of degradation. But in the little mini experiment I did on the right, I took EpiPens and took the covers off and put them in my oven at 150 degrees for 2 hours, which may or may not have degraded them. As we know, it may take more heat than that to degrade them, but it certainly resulted in no color change. And I froze them for 10 hours, and I certainly, as you can see there, had no color change. Well, could they have been degraded or not? Okay, maybe they weren't degraded. So I'm going to show you some better evidence that epinephrine can undergo significant degradation without color change. And these all come from studies of the effects of heat on epinephrine. And Rashid in his study noted that despite the significant degradation of epinephrine solution, no discoloration or macroscopic precipitates were apparent. Grant in his study said none of the solutions in this study, which was of exposure to high temperatures, underwent apparent discoloration or precipitation in spite of a marked degradation of epinephrine. And Church, in a study we didn't look at today, said it is possible that epinephrine may undergo significant changes in formulation while presenting no observable changes to indicate such changes. No discoloration, expiration date not exceeded. So the bottom line is that if the epinephrine solution appears discolored or appears to have precipitates, that's not good. But if it appears clear, that doesn't mean that it has not degraded. If you have exposed your device to high temperatures, you cannot be reassured by looking in the window and seeing that the solution is clear that that is an indication that there has been no degradation, because degradation can occur without color change. And that brings us to the end of this lecture. Thank you very much for your time. I hope this was useful to you.